All right, welcome everyone. Today you need to title your notes line of best fit. These tables I did provide for you if you want to print them out, paste them in your notes, or if you want to annotate on top of them, or you can write them. It's totally up to you. But the PDF is in our modules for the week. Yesterday we talked about lines of good fit, which we can estimate to the best of our ability by hand. Lines of best fit have to be done on either a graphing calculator or a computer. The computer will calculate for us exactly where that line of best fit is, where yesterday we were more or less estimating and finding lines of good fit. So you will need a graphing calculator for this. On Canvas, I linked for us in our module. So here's all the tables if you need those, and then you're on this line of best fit video notes. And you should have a link right above our video you're playing right here that says Desmos Line of Best Fit Calculator. So you'll want to click that. You're going to use that for our notes today and our activity tomorrow as well. So here we are going to, it's going to give you kind of an already filled in example. We are going to take this table and edit it so that it has our data in it instead of the sample data. And if you accidentally delete something or accidentally mess something up, just refresh your page and it'll set it back to this original starting point. So this table, I'm just going to fill it in with mine. So I'm going to highlight that first cell, and then if you hit tab, it'll take you to the right. So you can type in 39, and then you can keep hitting tab to move to the next one. So I'm just replacing all of the data that it had to start with the data on my first table. Okay. So I'm going to zoom out so I can see it. But you can see this line does go through the center of our data. Looks pretty accurate. And then down here, it's going to tell us what the equation would be. So it's telling us that this is our slope, our intercept, and then our correlation coefficient, our R. So if we now use this information, I'm going to scoot this over to write my equation. And I'm going to round to the nearest hundredth instead of writing out this whole thing. So I have a slope of 0.28, it looks like. And then I'd have a y-intercept of negative 22.88. So this is my equation. Also, they're telling us that our R is 0.97, which is a really strong positive correlation. And then this R squared is telling us that this is about 95% accurate. Okay, so strong positive, 95% accurate. Then it says protect the number of games won if there were 300 goals scored. Goals stood for X, so I can replace this X with 300 to answer that question. So 0.28 times 300 minus 22.88. So I'm just going to type that into my calculator. And I got 61.12. So approximately 61 games. All right, so we're just going to do this a couple more times so that you can get the hang of using our new tool, our graphing calculator. So Desmos we've done some activities on, but really it is also a graphing calculator. Again, you could refresh to reset it to what it did, to where it started, or you can just type in over on top of this table. So I'm going to do that. So here, I'm going to, highlight my first cell and replace it. And then I just am hitting tab in between to move from one cell to the next. And then these extra lines I'll have to delete. Okay, you don't want them in your table because we just want the data they gave us. All right, I'm just trying to zoom and make sure that it looks okay. It does look like my line is going through my points. Looks like a line of good fit, and it is actually a line of best fit since it was on a computer. So now I can look at my equation. So down here they're telling me my slope is negative 0.23 and that my y-intercept is 25.57 if I were to round that. So I'm going to write that on our slide here. $25.57. All right. So this is and then here, negative 0.99, that's a strong negative correlation. It's really close to -1. And then this is about 98% accurate is what that R squared means. Then it says predict the race time if you trained for 10 days. So I'm going to, again, days was X. So you're going to plug in 10 for X. So to answer this question, I'm going to do negative 23 hundredths times 10 was 25.57. So I get 23.27, and that would be in minutes. 23.27 minutes is what we would predict if they trained for 10 days. All right, we're going to do one more of these. So again, I'm going to go back to my Desmos. If you accidentally delete something you weren't supposed to, or just doesn't look right, go ahead and refresh the page so that it goes back to that original state. But I'm just going to start in my top corner and hit Tab to type in all of my data. So I'm just hitting Tab in between. And then there weren't any extra rows I needed to get rid of this time. So that should be good. All right. So let me see if I can find my points here. Okay. And that looks good. It looks like it's going right through the center as best as it can. So it is saying that my slope is negative 18.83 if I'm going to round to the nearest hundredth. And then it's telling me my y-intercept is 328.42. And then it says predict the number of bats on the 10th year. So again, year was X. So I'm going to plug in 10 for X to answer this question. I'm going to do it above this time just for space. And then these numbers are in thousands, just by the way. So I have 140.12 thousand bats. That's how many bats they predict to have on the 10th year, and they're going down. It looks like our population of bats is diminishing. All right. The closer the correlation coefficient R is to 1 or -1, the stronger the relationship. So if you ever get an R of 0, that means they have no relationship at all. This one is very close to -1, so it's very strong. Here, R squared also, that's not on our slide, but I want to mention it, tells you how accurate it is. This would be 99% accurate if you use that line to calculate anything else, to answer any sort of question. All right, so make sure you write this part down, and then you're finished with your notes for today. You are working on a big ideas assignment tonight.